So in this case, we're dealing with some problem solving. We have to deal with the definition of combinations and the definition of factorials to figure out what n is. So we have nc n minus 2 equals 15. What that actually means is we have n factorial divide by r factorial, which would be n minus 2 factorial, times n minus r factorial, which would be n minus 2 factorial. And that equals 15. Put out one set of brackets on the bottom, just put that in. So then the definition of n factorial would actually be n times n minus 1 times n minus 2 times n minus 3, and so on and so on and so on, until we multiply down to 2 and 1. And I've just omitted what I felt was necessary because we don't know what n is, we don't know how big that omission is. We do know that with any factorial, it always multiplies down to 1. The bottom, the n minus 2 factorial would be n minus 2 times n minus 3 times n minus 4, and so on until we multiply by 2 and 1. The n minus 2 factorial would actually simplify into just 2 factorial, which is going to equal 15. At this point, we've actually taken a relatively simple equation and expanded it into something more complex. But what we can do is we can cancel a lot of things off. We have n minus 2 on the top and bottom. We have n minus 3 on the top and bottom. We have n minus 4 on the bottom, but it looks as though it's not on the top. Really it is. That was just where I chose to stop writing out on the top. So we do have n minus 4 on the bottom and the top. We have all those terms in the middle. We have the 2, we have the 1. So now this simplifies down quite nicely. We have n and n minus 1 on the top. We have 2 factorial on the bottom, which equals 15. If we expand out the top, we get n squared minus n. On the bottom, 2 factorial is just 2, which equals 15. Now looking at this, we have n squared makes this a quadratic equation, so we're going to want to look to factor this if it's possible. In order to do that, that fraction needs to go, so if we multiply both sides by 2, can cancel it from the left. We get n squared minus n equals 30. And in order to factor, we need to have 0 on one side, so we'll move the 30 over. And at this point, we can think about factoring. Two numbers that multiply to negative 30 and add to negative 1. That would be minus 6 and plus 5. Can split this off now so that n minus 6 equals 0 or n plus 5 equals 0. We get n equals 6 on the left and n equals negative 5 on the right. Now the n equals negative 5 is actually a rejection answer because it's negative. N in all of these cases is the total number of objects we have to arrange. We cannot have negative 5 objects, so in this case, only positive numbers will be valid. Moving on to question 2, same idea. Top will be n factorial. Bottom would be 2 factorial times n minus 2 factorial. That equals 3. top would expand out to n minus 1, n minus 2, and so on, down to 2 and 1. The bottom, if we leave 2 factorial for the moment, n minus 2 factorial becomes n minus 2, n minus 3, and so on down to 2 and 1. That all equals 3. Cancel what we can, the n minus 2's. We do have n minus 3's even though it's not shown. Everything in the middle, the 2's and the 1's. So we get n times n minus 1 over 2 factorial equals 3. Distribute out the top, we'd get n squared minus n. 2 factorial is 2. That equals 3. And from here it's just the same process. We'll multiply by 2 left and right, so n squared minus n equals 6. Move the 6 to the left, n squared minus n minus 6 equals 0. This factors into n minus 3 and n plus 2. Split it off. And we get n equals 3 and n equals negative 2. We'll reject the negative 2 and our only answer will be 3.